Well, thank you, Dave. Good evening, everyone, and welcome to the seminar. I Let me just say that I kind of like doing uh, question and answer stuff. We do have the chat open. I've got the window open, so if you have a question to ask or anything, please don't wait until the end. Just go ahead and do it. Little background on me. I learned how to program and operate CNCs back in the mid 90s, 1995 or 6. And back then, the G code that actually runs the machine, without getting too technical about it, it's essentially a text file because the machines aren't that bright. And so, but back then you had to write the text file as a text. So line by line, X, Y coordinates, Z coordinates. It took, it could take days to write a cabinet or a program for making a simple cabinet side. Fortunately, things have come a long, long way since then. The software is much more powerful and versatile. The machines are more powerful and versatile. But I've been teaching and programming and operating and training operators and installing and servicing machines on and off for the last, since the mid 90s. And so it's just an area that I've really come to love and enjoy in my work. And so when I got the opportunity to write a book about it for the home hobby section of the business, I kind of jumped all over it, and it's been kind of a ride. But while the book is designed for beginners and for primarily for the what I call the desktop CNC market, a lot of the programming strategies and the things I talk about are applicable to professional shops as well. And I've consulted with professional shops for the last 20 years on their CNC acquisitions and operations. So for those of you who are in the business and are working with your CNCs, again, feel free to ask. A lot of the photos I'm going to show you are my benchtop unit. I just got a new one from ShopBot, which is kind of fun. We're playing with a better, more advanced system than my old 12-year-old one. But a lot of the things we're going to talk about are the same kind of things that you face in as a cabinet maker or as a furniture maker or whatever you happen to be making on your CNC. So one of the things that I did with the book was I've learned, and I know I learn more easily when what I'm trying to learn is in context. So, knowing how to figure out the formula for figuring out area of a given size doesn't really mean anything to me. But when you frame it in okay, if you measure the wall, you can figure out how much paint you need to buy in order to paint the wall. That makes sense, and that puts everything in context, so I understand the concepts better. And so in doing that with the book, what I did was I divided the book up into individual projects, and each one was designed to teach a specific skill set or a different tip or trick or technique. And so we start out in the book, the very first thing is how to make a proper spoil board for your CNC machine, basically an MDF tabletop edition that allows you to clamp your parts down if you're not using vacuum, but also allows the bit to cut through the part to cut pieces out of a larger sheet without damaging your actual physical machine. And so by taking the reader through that, and then I show how to make some simple clamping fixtures that go with it, and using the machine to make the parts that will then improve the machine. So that's where the book kind of starts out, and it's kind of fun. But one of the things about CNCs that I've always really enjoyed, and yes, there are some traditionalists out there who will say to you, "Oh, well, CNC is cheating. You're using the machine. You're not doing it like a craftsman would." And they say this usually with an electric router in their hands or an electric table saw. So I kind of laugh at that. But one of the things that the CNC is really, really good for, at least in my shop, it gets used probably as much for making parts, pieces, and improvements to my existing woodworking equipment. So let me I'm going to do a little bit of a screen share here. And all right, so I've got some of the images from the books here, and we're just going to go to throat plates, for example.
Excuse me just
So
a second, Ralph. Is everyone seeing the screen that he's sharing? Or is someone not seeing it?
I'm
you
seeing
should
it.
see a table saw blade in the middle of your screen right now.
I see it.
Okay, sometimes it gets hidden behind, and I just want to make sure. Sorry, Ralph, go ahead.
No problem. So the zero clearance inserts for the table saw are a very common thing for people who have CNCs and anybody who has a table saw. CNC has nothing to do with it in and of itself. But, I used to have piles of these hanging around, or, I'd have to make them with multi-steps with the hand router and a saw and all the other things. And once I was able to minimize this just a little bit, once I was able to create a program in the CNC. So I basically measured and drew out the insert plate. Now notice this is upside down and backwards from the way it sits. There's your finger hole, and here's where the blade comes through on the left-hand side. But here, we're going to mill it from the underside for a couple of reasons. Now, the main reason is for this slot here in black, which is if you've ever built a zero clearance insert for your table saw, the blade actually comes very close to the surface of the table saw. And if you use a 1/2-inch piece of plywood like we're doing here, it doesn't sit all the way flush. Your blade doesn't go down deep enough. And some people will put a smaller blade on to do that. But here with the CNC, we're going to cut that groove on the underside as a clearance to allow the blade to turn on and start spinning before you raise it up and make your zero clearance. So that's one thing that the CNC gives you. Now we're also milling the locating holes for the set screws for the leveling. But notice the red dotted line here. This is where I would have the opening for a dado set. And so the cool thing about doing this on the computer and in the CNC is that I can do either of these, or I can do both. And so here you see a picture, and this is in the software. You can literally, it works very much like, one of the nice things about SketchList is that we get to see what we're doing as we're doing it. And with the software, this is VCarve, you also get the ability to see a preview of what your machine is actually going to cut. So in this case, I've cut out a pocket underneath the throat plate for both. I can use this as a zero clearance insert for a standard 10-inch saw blade or for a dado stack. So I could literally make these up ahead of time and then use them for whichever I want, or I can, create the individual programs to make either one of those. It gives me the ability to do that. And the throat plate on the table saw is just one. I was making some throat plates for my bandsaw and my router table over the last weekend. So this is one of the types of projects that you can do. And here's the tool paths being shown how they're going to cut.
Hey Ralph,
go ahead.
I'm sorry to interrupt again. I don't see the detail, and a couple of other people are responding the same way in the chat box.
Okay, let me go back. You can see let me upgrade the image here. Maybe that'll help. Let's see. The screen only gets so big. All right, so
I see like your Explorer with a bunch of thumbnail images.
Really? Oh, okay. I'm sorry. That's why. Let me do a new share. And there we go. Now you should be seeing the actual photo.
Got it.
Okay. So that's my apologies. That's what went bad there. Am I still sharing the other one, or is this just this now?
On my computer, this is overlaying the other, so this is fine.
Okay. So and let me see if I can. Okay. So I can use my arrow keys instead of the mouse to move through. So let me go backwards a little bit. So there's the throat plate we were talking about, and then here's essentially the drawing of it. This is a 2D drawing. It came out of DeltaCAD in this case, and you can do, but you save it as a DXF, which, by the way, you can do. You can save DXFs directly out of SketchList and import your cabinets or whatever you're designing in SketchList into your CAD/CAM software, just like I did here. And so but all of these lines are two-dimensional. The computer can see them, but now we have to go in and apply the tool paths, which are the blue lines here. So this turns into a 3D, this 2D drawing turns into a 3D operation by assigning tools and then telling the machine how you're going to cut, how deep to cut each piece. And so, but this is a project that I go through in the book, and I show you how to make a throat plate for your saw. But in the process, hopefully you learn about being able to augment your existing equipment with the CNC and some of the stuff that it can do. And so here's another. This is the tool paths being shown. It shows the direction that the tool is cutting. The red line is what we're actually cutting on the outside perimeter. And you'll notice that the line with the arrows on it is slightly offset to that. That's showing me the center line of the bit, so I can make sure that I've got this aligned properly. I don't want to cut on the line. I want to cut with the edge of the bit on the line. So it's the center line is offset. And so this is all, just part of the preview process that allows you to see before you cut any stock whether or not what you're doing is probably correct. And so here we've got the thing mounted. Now, remember I talked earlier about the spoil board. That's this MDF piece with the slots in it. Those are T-slots. The MDF below is the bed of my machine. I don't want to cut into that because that's physically part of the machine. So this MDF spoil board allows me to not only use T-bolts to clamp the board I'm working on in place, but also when I cut through, I cut into this spoil board and I don't cut into my machine. And that's why it's called a spoil board. You actually spoil it as you use it. So that allows me to do everything I need. But notice that the middle part of and I'm pointing to the screen, which is silly because you can't see me doing that. The center part where we've made the cutout for the throat plate for the blade or the dado stack isn't cut all the way through. I left that 1/4 of an inch thick, so it's strong enough, thick enough to be an effective surface for cutting on. But the blade can clear it and will easily cut through when you set up your zero clearance insert. So this is a really nice way to augment your existing equipment. And the next time you need a new throat plate, all you got to do is cut the piece of stock, call up the program, and you've got an exact match for what you're already working with. So, and this is just. This one actually has a 3/8 wide groove in it for Freud's finger joint bit. So I'm going to pop out of that real quick. And I closed the window so it stopped the screen share, but let's go into the next one. Yeah, see, when I opened up the screen share, I couldn't see the text. But let me get into where I want to go first. So let's look at the coasters. You'll like this one. And go back to here. And all right, screen share, and I don't want to do that just yet. I have to remember that I have to call up the photo first and then do the screen share. All right, so there we go. So now you should be seeing my CNC, and I'm using a nut driver to put a part on it. Everybody see that photo?
Yes, I do.
Okay. So the project that we're doing here is a set of coasters and a little tray to hold the coasters. And it's a very nice little piece. It makes an excellent gift. But the reason I included it in the book is because this process, I purposely made the tray for the coasters so that it had to be milled from both sides. Both faces have to be milled. Normally on the CNC, I try to always only work off of one face because that way you don't have to try and realign the part and relocate it, because it has to be done very accurately when you're working on both sides. But it is a good skill to have, so we included one in the book. And let me make sure this is active. There we go. So I'm just going to I'll skip around a little bit because these aren't necessarily in order. So what you're seeing here is the actual two pieces of the tray for the coaster cut out. Now, the fiber board underneath, the coaster set itself is cherry. The fiber board part underneath is the fixture board. Now, what I did was I programmed, let me go back here for a second. So this drawing is basically part of what you see, what you just saw in the cherry, and we'll go back to that in a second. But you'll notice that the outline of the parts is there. There's a logo, my Wood Academy logo is there, which I'm going to cut into this. That's why it's two-sided. But you'll also notice on each end, the whole part is oversized, and on each end there's a pair of concentric holes. The red line, the red circle is 3/8, and the inner circle is 1/4 inch. So what we did, or what I show you, is we take this part here, this press board, and it could be MDF, could be anything. It's just scrap. Lock it down to the table, and then I use the holes that you saw in that drawing on each end for drilling a 3/8 hole, which we then put a threaded brass insert into. The threaded brass insert holds the nylon bolt heads that you see on both sides of this piece of cherry. That's what locates the part. And so the first step is we take the blank of cherry and we use the CNC to cut the 2 holes, and then those get bolted onto this fixture board. And when I want to flip it over and mill the other side, I can release those 2 screws, flip it over, screw it back down. And since everything references off the same point in both cases, then the logo that I put on the other side will match up with the cutout and the parts that are being done here. Now here, if you look closely at this photo, you can see that the part is cut out. So there's one side and one end for the case, the container for the coasters here. But there's also, along the bottom edge, there's a groove to hold the bottom of the tray. And I also used a 90-degree V-bit to cut 3 lines in those 2 pieces. So these 2 pieces will actually basically fold together at the center to become half of the tray, and then the outside edges are also mitered. And what this means is that when we're done we make 2 of these, because each one is half the tray, and then you can literally assemble the tray right off of the machine by just taping the pieces together with the bottom of it trapped inside the groove that we already cut. So the CNC is doing pretty much all of the work. And let me see if I've got some nice photos of it. Yeah, so here's a picture. This is the preview of that view we were just seeing. So you've got the V's that's where you create the miters. Along the bottom here, you've got the groove for the base. And then I put tabs in to hold the parts as I cut them without cutting them fully free so that they don't go flying as the machine cuts them. And so here's the whole set. Obviously, the coasters are pretty easy to do. There are some tricks to that. I show you how to use a proper bit so that the inside corners are rounded over so you can wipe them clean very easily. I show you how to import the image that's carved into the bottom. But here you can see, and this is why we set up this the coaster tray the way we did. It has to be milled 2 times. On the outside, you have the Wood Academy logo that I carved in, 1 on each side. Here's a fun fact. If you were doing something like this for a wedding, you could put the bride's name on one side and the groom's on the other, and it would make an awesome wedding gift. But that's on the outside of the parts, which in the part we were looking at earlier, here is underneath. I've already carved the logo. It's underneath at the bottom of the part. So we had to cut both sides in order to do this because the miters and the groove for the bottom of the tray had to be cut on the inside of the parts. So this had to be cut on both sides. And it used to be a little harder to do this. VCarve now allows you to actually ghost both sides together at the same time and see exactly how everything lines up when you're doing 2-sided machining, which is really nice. But this is an example of 2-sided machining, and we do this in the book, and then you can follow it step by step and see all the bits and pieces of it and how it works. So it's a lot of fun, and I have a lot of fun doing this. I'm going to stop.
And this sells for $29.95. Is that right?
What's that?
The coaster set.
We'll
flash a buy now button up a little later.
Well, actually, you know, the book itself is only is on sale right now on Amazon for $19.99, so it's a bargain. You get the coaster set
Yeah,
for that.
plus the cost of the CNC machine, but we're not going.
Well,
we don't count that.
Yeah, that's you know that's not too bad. All right, so I think I can pop into this one and screen share because one of the other projects that I do that's really kind of fun is, let me make sure I can do what I want to do here. Is this going to let me? Nope. Let me stop sharing for just a second and get rid of that. And I'm going to go back and close that out. Yeah, all right. Awesome. Now I can do the screen share. All right, you should see the machine cutting a piece right now on your screen. Can you see that, Dave?
Carving out a.
Yes, yes.
Yeah, got it.
All right, so let me find the actual luminary drawing and then I'll explain to you what's going on here because this is kind of an interesting piece the way it was created. All right, so that's what we're making. Now, this is what I call a luminary. So the carving that you were just seeing is on the inside of these parts. And when you put a candle inside, it glows through. I've left the last veneer layer on the plywood, but nothing else. Everything else is carved away behind it. And I should have a picture of it without the candle. There it is. Whoops. So this is what it looks like without the candle. And you can kind of just ghostly see the candle-ish image there. But once you light it up, you get the really cool effect of that. So, and the carving of this is part of the fun, but for business people and for professional shops, this is less important. The important lesson in this project is right here with these tabs and slots. And I'll explain what I mean by that. As you all know, plywood is never the same thickness. Okay, this is 1/4 inch plywood, but it's not 1/4 inch. It's like 0.21 or 0.22 or something. And the problem is when I do the programming for this, I want those slots cut into the side of this piece and the tabs to be the same thickness. But if I take this program a year from now, buy a different piece of plywood and try to make the part, I have no idea if any of that's going to fit. And so what I did, you can see it there. So here, as we're cutting this out, and I've done the carving, but as we're cutting this out, I'm pocketing out where the slots are going to go. And over here, these are where the tabs are going to be. I created pockets, and those pockets, hang on. Because I don't know the thickness of the material, when I touch off the bit to set my Z height, the top of my material, I don't want to rely on the material because it varies. So if I use a setup block and everything's programmed off of that 1/4 inch setup block, then all of the thicknesses, the material left behind is what's important, and that's what I can control. Normally, if I need a pocket of a given depth, I touch off the top of the material and the pocket will cut to exactly the depth I need. But in this case, I wanted to leave stuff behind. So I cut the slots to a particular thickness, I think 3/16 in this case. And these pockets are taking away just enough material to make the tabs that will cut out of them 3/16 of an inch thick. And you can see there, in here, you can see the tabs are inside those pockets. So when I finish cutting this out, the tabs are exactly 3/16 of an inch thick, and the slots here are just a whisker over 3/16, so the tab will go through without rubbing. And you get a really good fit here, and it all works out because I was able to do all that in the designing and in the programming. Now, this is a luminary, and it's kind of a cute thing, but I want to see if I can find a picture of the tab here real quick. This was experimenting on how deep I had to go to get the glow to come through. So with these tabs and slots, we can pocket out the individual areas, and so that's what the toolpath here is showing, is the pocketing out over the tabs. I'm doing tabs and slots here, but think about this with cabinets for a second in your mind. You've gone into SketchList and you've designed your cabinets. And I personally, in my home, when I'm making cabinets for my own home, I like dadoed shelves and stretchers. Okay. It's the best way to build a cabinet. It's the strongest way to build a cabinet, and everything is located on the CNC. So that's what I like to do. The problem is, as we talked about, the plywood is never exactly 3/4 of an inch. And you rarely, first of all, I rarely have the plywood in place when I'm programming to measure. And more importantly, I don't want to have to reprogram it every time I make a cabinet. So if I cut the dados to 11/16 of an inch wide instead of 3/4, and then I do a little rabbet cut on the edge of the deck or the stretchers that are going, whatever's getting placed between the cabinet sides, and mill that down to 11/16 of an inch, my dados are going to fit perfectly in the, or my shelves or whatever will fit perfectly into the dados that we're creating, and I get to control everything that's going on without, without worrying about the actual thickness of the plywood. And that makes a huge difference. And also, because I'm controlling everything, the width of my cabinet from side to side will always be exactly what I expect it to be. And I don't have to worry when I put a string of 12 cabinets next to each other along a wall that the overall length is going to suddenly be more or less than I anticipated because the thickness of the plywood changed. So this is a technique that, although I'm applying it to a very small CNC operation here, you can extrapolate into full-size cabinets or anything else that you're building when pieces have to mate very, very accurately. So that was kind of fun. All right, so are you cutting everything on one surface? In this particular project, yes, we were. So that let me go ahead and share that again. So here, the black part where you see the candle drawing, that's what creates the light part. And I use a V-bit, and I've cut almost all the way through the material, but I very carefully controlled the depth of cut, which I can do in the software, to leave just the outer skin, the birch veneer face of the material behind. And let me show you again that test. So on the left here, this is a piece of plywood with no carving. Then I did a test cut to prove the carving out, and I go through all of this in the book. And I set the depth at what I thought it should be, but it was a little bit too, not deep enough, too thick left over, because this is sitting in the window here in sunny Florida and you can hardly see the outline. So then I reset the depth, cut another test piece, and that's over here on the right. And you can very clearly see that the candle image goes through nicely. And the dark and light spots are made by having a little bit more or less material left behind. And that is literally based on the line drawings. I have one closer view here. All right, there it is. So this is the drawing that I started with, and where you see masses of dark that are supposed to be shadows. Woodcuts like this work really awesome for this kind of carving. So where you see the black lines are heavy, you're going to have the blacker and wider the line, the closer it is to the surface. Anything that's not that's white on this image is uncut. And so using a V-bit, and then with the light shining through, this is the effect you get here with the V-bit. So this would be carving it just by eye if we wanted to make a visual carving, but by carving most of the way through, you can see it looks very different in the preview. That's leaving behind the thinnest parts are the ones that are going to show through as white instead of black on. So it's like a reversed image. And then you can see here that we've carved away a lot of the internal material, and this darker tan stuff here is the backside of the birch veneer layer of the plywood. The CNC allows you to have that level of control where I can cut right up to that final veneer of plywood, but not cut through it. You get that level of control, and part of that is using the spoil board, and we plane it down so that we know it's absolutely parallel to the head. And so then you get this cool drawing. But this project was really created to do to make the tab and slot thing. But yes, when I'm programming, I generally want to do everything on one side of the part if I can. And that's because I don't have to, if you go back to here, this is a cutout piece of plywood. It's a little bit bigger than what I need to fit all of these pieces on, but I've got to have a little bit of room for my clamps. But then the machine's going to cut these all out. So if this piece is not perfectly located on my machine, if it's a 16th or a 32nd left or right or up or down, it doesn't matter because I'm cutting them out after I'm done anyways. So the sizes will all be correct. When you do the flipping operation or the milling on both sides, generally your part's going to be already cut out. It's already going to be the size it needs to be, or sometimes you can cut halfway through on each side. But you need to be able to locate those parts much more carefully on the machine because you absolutely have to know everything has to line up. Here, I don't have to worry about it because ultimately it's all getting cut off this one setup. So there's really very little tolerance between one setup and another. And any machinist will tell you, if I didn't cut it on this setup, I can't trust it. So that's kind of how we work here. But a lot of this was based on surfacing off of a known setup block rather than relying on the thickness of the material. So any questions on any of that? Nope, we're good on that. So let me go to one other project that we can look at. Let's see, let's go for the clamps. All right, let's screen share that. So I prefer, in the book, I show you two different types of clamps that I use. Now, with big industrial machines, you often have vacuum as well. But when you're working with small parts, vacuum holding is awesome. But it really is completely dependent on the square inches involved in your part, because you're vacuuming the air out from under. So your air pressure is literally 14 pounds per square inch, or in the case of a vacuum system on a CNC, I estimate about 10 pounds per square inch. So the more square inches, a cabinet side or something like that holds pretty well, but smaller pieces don't like to hold by vacuum. So you have to sometimes use clamps or clamping operations. So these clamps were cut out on the CNC and they're arched, but I also was able to, I'll show you how I used pockets to not only control, when I glue these together, everything goes into pockets, so they self-locate when you're clamping it together. It makes it a lot easier to make. But by controlling the depth of the pockets, I can also control the width of the slot that the bolt goes through to hold these down. Let's see, click on that. There we go. So here you can see, this is one of the images from the book. So I cut out the two clamp sides here and here, are cut out there, and you can see that they've been pocketed. So it almost looks like little macaronis or hot dogs or something. And these are the spacers that go in between. Since I cut everything out of 1/2-inch plywood, I made these pockets, I think 1/8 of an inch deep each, or a little bit less, just a whisker less, so that the gap in between the two sides when you glue it all together is somewhere between 1/4 and 5/16 thick. So a 1/4 20 bolt goes right through and fits perfectly. These disc clamps that you see holding this piece, I like these for thinner material. They work really, really well. But sometimes for thicker material, you need something a little more with a little more reach, and that's what these are for. So again, this is showing off the circle clamps. They've got a little lip on the underside. So when they're holding, they're not only holding the part down from the top, but they're keeping it from moving side to side. So that gives you two different clamping options in the same part, and I really like that. For thinner materials like this 1/8-inch plastic over here, the lip won't work, so we just flip the disc over and it can hold directly. Being off at this little angle doesn't really hurt anything. And so there's that same part just before we started cutting out the other clamps. All right, we'll go through this real quick. So there's the part being cut for the disc. And one of the nice things about working with the CNC also is you can see that this is a piece of scrap that I had from a different project I think this was actually, I cut, one of the projects in the book is to make a push stick for your table saw. And that's the leftover from cutting out the push stick. And by creating the program for this one disc as a single piece, I wanted 4 discs, but rather than drawing or copying and pasting 4 discs into the same program, I made the program for 1 disc so that I can cut one out whenever I need to. And by positioning my router and resetting the start point, I can cut them out anywhere on a piece of scrap I need to. I don't need to measure this scrap. I don't need to know how big it is. I can just position the head, set the zeros, and go ahead and cut from where I'm at. And I can really use up my waste quite effectively that way. So that's another technique that we talk about in the book. And these are the commercial clamps that come with many of this type of machine, but they only give you 2. And really, that's not enough to hold when you're trying to mill into those parts, which is why I make my own. So again, here's those little parts for the arched clamps. And you can see that the pockets are actually a little bit oversized from the actual radius of the parts. And that's so that the bit cuts all of that away and you don't have any weird leftovers at the edges that have to be sanded. So there's the tool pathing. And again, everything works out here, but the tabs that are holding it over here probably aren't going to work very effectively. So I repositioned the drawing, and one of the cool things about the software is that you can actually very often you can just recalibrate or recalculate the cut path, and you don't have to redo all of this. It just automatically adjusts out. But again, the darker parts here are the pockets that are cut out. So as you can see, these little kidney-shaped pieces will fit in there, and that will create the clamp. Come on, you're supposed to be, maybe we're at the end of the photos, but yeah, that creates the clamp. So, so these are all techniques that I've learned over the years for doing this. And tool choice is a huge, huge deal. So, you know, when you're working with your tools, this particular machine, these benchtop CNCs are generally not equipped with tool changers. So to change a tool, you have to have a separate program, and you have to stop and, you know, set new tools. And it's a workable solution, but it's not fast. So very often, if I need to cut out a pocket or make a hole, I may have to use a smaller bit for that. And I may keep that bit and do the pocketing for like this piece here, even though I could use an 1/8 inch bit. And even though an 1/8 inch bit will take longer to make that pocket than a 1/4 inch bit, it doesn't take as much time as changing bits. And so I use a lot of stepped bits. I use a lot of like round over bits. You saw earlier, we used a V bit for making a miter cut. There's a lot of tool choice techniques that you can make that will save you a lot of time, both at the CNC and further downstream from the CNC when you talk about assembly of cabinets or anything else. I've found typically that an extra minute or 2 of programming and runtime at the CNC can very often save you, 10 to 15 minutes per minute. You get a multiplier of saved time down the road from doing that sort of thing. So, any other questions? Anything else anything in specific people want to know about? Specific questions about, machines or tooling or SketchList or my experiences or anything else? I'm more than happy to, we have a chat feature everybody can ask, and I'll be happy to talk about it.
What is your new machine?
I just got a ShopBot desktop. So ShopBot actually makes full-size machines. They're entry level, but they're very, very good, and I've always really liked them. And they actually were kind enough, and actually because of the book, they were kind enough to actually. I've got one on loan from them for the next year or so. So that's kind of fun. It's a relatively new machine, and it's the one you see in my images. The one that you were seeing in all these images is. It's actually the CNC Shark from Next Wave Automation. I have one of the first ones that Rockler ever put out. And in fact, I did a lot of the original how-to and user instructional videos for Rockler. But the machine's at least 12 years old. And so it's very early technology, and the body is all basically nylon half-inch thick material. So it's not terribly rigid. It served me incredibly well for 12 years. I've gotten a lot of use out of it, and I've made a lot of money with it. But it's, it's nice to step up to something that's a lot more advanced and more rigid. But I will say that this machine, being 12 years old, its power comes from a Bosch Colt 1 horsepower router. I'm on the third one in 12 years. So, because hand routers are not made for continuous use, cutting 20 or 30 minutes into a piece. But honestly, I think that going through 3 routers in 12 years with the amount of work that this machine gets is pretty good. But the actual machine itself, I've never had a breakdown and never had to replace any parts on this machine so far. So, and again, this machine gets used a lot. It's not something that once every 6 months or on the weekends. It gets used quite heavily. So I've got no complaints about this machine and how well it's worked. But for this kind of desktop machine, you can build your own for $1,000, or the desktop that I have runs about $7,000. And they do make a tool changing version of it, which requires a much more expensive spindle that retails at about $15,000. So you can spend as much as you'd like, but at $15,000, now you're starting to approach like actually getting a full size CNC territory. So I'd get a 4x8, but then again, I don't have room for it. So in my shop, the desktop is the right size because that's what I have room for.
Is it 4x4?
No, it's actually 24x18 is the actual working area. The machine itself is probably about 36 inches square, but you'll notice on the photos that I was showing earlier, and let me screen share again real quick. So the spoil board that you see here with the slots in it is not the same size as the bed of the machine. And this is something to consider if you're thinking about buying a machine. The size of the machine is one thing, but the spoil board, you want it to be just a little bit smaller than what we call the working envelope of the machine. So I want to be able to plane this board down, to shave the top of it off very lightly so that it's absolutely parallel in the Z-axis with the travel of the head. That way, when I do the lettering, when I do carving with logos and stuff, it's all exactly accurate. But in order to do that, the head of the machine has to be able to travel across the entire spoil board. So this one is about a 22-inch square working area. The desktop I just got is 24 wide and 18 deep, and that's actually the working area. So that's the size of my spoil board. The machine itself is a little bit bigger than that. And that's typical. That's very, very typical that the working area and the machine are not the same size, because you have to have the support structure around the working area. But if you're looking to buy a machine, then that working envelope is one of the critical dimensions that you really need to think about or pay attention to when you're shopping them. And I'll say that the entire first part of the book is looking at, what criteria you should be looking at. I don't recommend any particular machine or brand, but I do talk about, the space you have available to work with, what kind of work do you want to do with it, what's your noise capability. Mine's in my garage now in my house. I used to have a separate shop that I rented, so I didn't care about noise or dust. Now my shop, since I moved to Orlando, is in my garage, and my wife very much cares about noise and dust. So that had to come in, that had to factor into which machines I wanted to buy and such. So I discuss all of that in the book, and we go through it pretty well. And again, anybody who's here, and certainly anybody who buys the book, and even if you don't buy the book, if you have questions, you can always feel free to reach out to me, and I'll be happy to talk about, whatever questions you have and answer whatever questions I can.
Is anyone in the group considering going to CNC, or does anyone have a machine?
I just recently got a 4x8 CNC to cut out cabinet parts.
Nice. What brand?
It's a General Gorilla.
Nice.
It's 2016, I think, so 5 years old.
Yeah. No, the General tool, I'm very familiar with. What are you using for programming?
VCarve and
Okay.
and then trying to get from SketchList to that to cut out my cabinet parts.
Yeah, you may want to reach out to me at some point in the future, because I've done some of that, and I've been working with Dave on it. It is pretty easy to do, but VCarve is an excellent program. I still think it's probably the best value out there right now, because it just works with every computer, every machine. I have yet to find a machine that it doesn't work with, and I don't do a lot of drawing in VCarve or any CAD CAM program. Most of them are very difficult to draw in. So I either do my simple drawings in something like DeltaCAD, or if I'm doing cabinets or furniture type work, I start out in SketchList and I work from there. So it's pretty easy to do. David apparently has the Shark also, 10 years old and going strong. It's a great machine, man. I've been very happy with mine. It's been just a lot of fun. And like I said, I've made a lot of money on it over the years too. I've carved all kinds of things and made all kinds of parts for people. And I've been literally programming and operating CNCs for at least 25 years now, and they fascinate me. I love to watch them work. I was running one just today at work, doing new product development with microjig. So just have a ball with them.
So, Chris, in case you hadn't seen it or don't know about it, one of the things that Ralph had done for SketchList users, I don't know, it was a year ago or 9 months ago, was a demo on taking the DXF file from SketchList and working with it in VCarve. And if you want to find that, if you just Google SketchList VCarve, I think it'll pop right up at the top of the list. And what happened was I basically Ralph just takes the DXF file, brings it into the VCarve, and shows how to get that to work. But importantly, I think, is that he does an excellent job of telling everyone why he's doing something. And I just learned so much about it, like the the ramp up function and all those little things that he knows. So I would recommend that you take a look at that video. And
I've seen it. It's cabinet side.
I'm sorry.
I think I've seen it. It's one cabinet side.
Yeah, that's right.
Yep.
Yeah.
Yep, I've seen that one.
Yeah, and in the book, I do explain ramping, and actually with the coasters, I actually show the coaster project. I didn't really show it in the discussion we had here, but I talk about the lead-ins and lead-outs and why you use them and how to use them. Especially when you're doing cabinets and stuff, custom tooling, and I don't get into that in the book so much, but I've done seminars at IWF about custom tooling. There's a lot you can do to speed the process, and you'll learn that as you work with your machine. But it's just amazing how there's so much to learn. And honestly, when I used to teach industrial, I used to set the machines up and then spend a couple of days with the operators training them how to use it. And I would tell them that the learning curve before you get really comfortable and proficient is it's about 6 months. The first couple of months I used to work in cabinet shops, and when you start, the crusty old guy in the back is like, CNC, I can make a cabinet faster than you just made that. It's like, yeah, today. And then about month 3, I can do it as fast as he can. And by month 6, he can't keep up, so there's a learning curve to it. And I also used to recommend to people quite often that, I'll teach you what you need to know today to get running, but let's talk about 6 months to a year from now, having me come back and do a concurrent training, because right now, by the time you learn just the basics, your brain is so full, you don't even know what to ask next. And so after you've had a chance to run the machine for 6 months or so and get used to it and really know it, now you've got a list of questions. Yeah, I want to know how you do this, or can I do that with it? And that's when having an expert come in and retrain you is really, really helpful. So, I did that for a great deal of time in my career, was teaching and running CNCs and all sorts. So,
David, what sorts of things are you using your CNC for?
Oh, there you go. Sorry, took a minute to unmute. I use it for all kinds of things. Very similar building, lots of jigs, doing production work. It's just versatile. The other day I cut aluminum with it for a project. So
Yeah, it's what I found is that people tend to buy a CNC with an idea in mind. Oh, I'm going to use it to do X. I'm going to use it to make cabinets, or I'm going to use it to make signs, or whatever they decide to use it for. And once you start learning the capabilities, all of a sudden it's like your mind expands and you've got this, I can do all these different things with it. And, David mentioned jigs, templates, there's a lot of pieces that I'm going to template route in my shop. I'm going to use, rough the pieces out with the bandsaw and take them over to the router table and or the shaper and do a template route. The CNC makes the templates instantly and they're perfect. As long as I've got the drawing right, I don't have to worry about screwing it up. I've made template sleds where, the part is clamped to a sled. And when I cut the sled base out on the CNC, the actual profile that I want to cut, the template profile is built into the bottom of the sled, so I can follow the bearing along that way. All of these things become so much easier to do with the CNC. And let me see if I can. One of the in the book, and actually, if you go to the Amazon listing, there's quite a few photos from the book that they've included there, which is kind of cool. One of the things you can see is that I built a steady rest for my lathe, and I could have made the same steady rest using traditional tools in my shop, but doing it on the CNC was a whole lot faster and a whole lot more accurate. And because I was drawing it in the computer to begin with, I was able to make the sizes needed for several different lathe sizes. And actually on my website, woodcademy.com, you can download the DXF files for making that for free. And the DXF file, you pick the size swing that your lathe has, and you can create the same steady rest for that size. And the computer makes that all possible. And the beauty part is that storing the programs costs almost nothing. The programming is not data intensive. The programs themselves don't take up a lot of space, and the G codes take up their text files. They take up almost no space. So I very rarely delete a program. You have to be very careful to name them so you know what's the most recent and the proper one. But that's just getting into good habits about naming conventions and how you store things. But it's a really it doesn't cost you anything to store. So why throw them out? You may want them again someday. So.
Anyone else? Comments or questions? Coming to the end of the hour. Just want to make sure that you get your viewpoint known or question answered.
Get your money's worth.
Get your money's worth. Yeah.
Worth every dime you paid for it. So yeah, and again, I would invite anybody, whether you buy the book or not. If you guys have any questions as you go forward and you need an answer, you can always reach out to Dave. He knows how to get a hold of me, and you're welcome to contact me and email me and ask questions. And if need be, we can even schedule a quick phone call to discuss it. I'm always available to do that.
I just had a quick question. If you're doing furniture or something in SketchList that has a curved part to it, is there a way to transfer that into VCarve?
Yeah, actually, Dave, the leg for my trestle table, my dining table, had a curved part underneath, and that translated just fine.
Perfect.
I seem to remember that, but basically, Chris, any curves that are in the DXF, again, looking down at plan view, and again, you're doing cabinets, so you know exactly what I'm talking about. You're basically drawing on top of the sheet of plywood. If you can draw that curve, it should translate directly as part of the DXF. So
okay,
I believe that that's the case, but I'll be honest, it's been a long time since I played with it, so because I don't have a full-size CNC. So maybe Dave and I'll have to look at that and see what we can figure out.
I think in a meeting a couple of months ago, it wasn't a CNC meeting, but one of the users, a couple of the users agreed that the technique they do is they shape that board. And Chris, while you're in the shape function, what they do is they capture that curvature, they capture it and put it out as a PDF file, which then they can incorporate somehow. I don't know.
Yeah, you can import a PDF or any image file into VCarve and then trace it. So that may be how they did it. I don't know, but remind me, Dave, and you and I can play with it a little bit and see what happens.
Yep, for sure.
Thank you.